All right, here we go. This is chapter 4, so I guess this is section 4.1, and it deals with what we call quadratic functions, okay? We've been looking at functions over the last week or so. We've discussed linear functions that you did last year as well, that make a line, right? These are another type of function called quadratic, and they show up in a form like this, okay? Call this the general form, f of x. We know that y and f of x are interchangeable, ax squared plus bx plus c. I've got a stipulation here that a can't be 0. If you give it a little bit of thought, a can't be 0 for a variety of, well, not for a variety of reasons, but mainly because if a was 0, this would disappear, and you'd simply have bx plus c, which would be a linear function. Okay. A couple points about a quadratic function. First of all, it is what we call a second degree polynomial. Okay, meaning that the exponent here is a 2. This has an exponent of 1, and all the variables have an exponent that are positive integers. Okay, so second degree polynomial. They have third degree polynomials, so it'd be x cubed, x squared, x. Okay, so this is a second degree polynomial function. It is also, it takes the shape of what we call a parabola. Okay, now if you wanted to graph this quickly, what would happen is, well, if we made a table of values, right, let's choose our values 2, 1, 0, -1, and -2. We'll choose those values for our x, so 0, 1, 2, -1, -2. If you square it, let's look at just the most basic function, y equals x squared. 2 squared is 4, 1 squared is 1, 0, 1, 4. So we'll see that you end up having the same thing on the right side as the left side. And then we go over 2, we go up 1, 2, 3, 4. So we have kind of like a big U. Here we go. Notice that this is not a point. Okay, this is not pointy. It's actually a curve in there. Okay, so this is the most basic form of a quadratic function. Just y equals x squared. You'll hear me say a lot 1, 1, 2, 4, and then 3, 9. Okay, just to get the basic idea of what this parabola looks like. Now, we've looked at other functions, the absolute value as well. We know that if we want this to maybe to go down, then we probably have something that we can remember, right? So first of all, these parabolas, they open up if the a value, if this number is positive. So if it's positive, then it opens up. That means the opening is up. If the a is negative, so it starts with, like, say, a -2x squared, then it would be opening down. Okay, that's the first sort of transformation that we're going to look at. Next up, we're going to look at a bunch of points of interest, okay, and lines of interest too. So the first thing that we want to look at is what we call the vertex, right? And if you look at these two situations, the vertex is the top or the bottom of the function, right? So we call this a maximum because it maxes out, and we call this a minimum because it minimums out. So if it opens up, you have a minimum. If it opens down, you have a max. All right? Y-intercept. So notice that if you have a function here, ax squared plus bx plus c, for your y-intercept, it's where x is 0. So if x was 0, that's gone, and you simply have y is equal to c. Okay, so that's the easiest way to find the y-intercept. For an example here, 2x squared minus 7x plus 1, you know it crosses the y-axis at 1. All right? Now, the x-intercept is where y is equal to 0. So our function that was originally f of x, for example, up here, or y, we're now making it 0. Okay, so it's where it crosses the y-axis. We've solved these before. You end up with a quadratic that you need to solve somehow, right? For example, 0 is equal to x squared plus, I don't know, let's make it 7x plus 10. Okay, if you factor this, right, you're going to get x plus 5 and x plus 2. And that tells you where your intercepts are, the solutions, right? So first of all, you have to factor to find the x-intercepts. And if this is equal to 0, we know that x plus 5 is equal to 0, or x is equal to -5. X plus 2 is equal to 0, or x is equal to -2. And these are my two intercepts. that is where the graph crosses the x-axis at -2 and at -5. Okay, so now another question that we could ask is how many x-intercepts are possible? How many x-intercepts are possible? Well, we have 2 intercepts. Let's call them x-intercepts, right? That's one possibility if it crosses twice, like this. Or it could open down and cross twice like this. Okay? Another possibility is that we have 1 x-intercept. Sorry, let's put an x in there again. And that would be if it just touched, went like this, up or down. Okay? You can think of that as a bounce, kind of. All right? Let me just find a blank piece of paper. And let me see this side here. There we go. How many x-intercepts are possible? So I've got the, what do we have here? I've got the 2 and the 1. Sorry about this graph down here. I'll just finish this off here. And we also have a situation, well, what would happen, so let me slide this up here, guys. Sorry about that. I'll get this sorted out for you. What about if I was up here, or down here, or over here, or down here? That's a situation where you have 0 x-intercepts. Okay? It doesn't have to cross the x-axis. So the idea here is that you can have 2 x-intercepts, 1 x-intercept, or no x-intercepts. You're never, ever going to have more than 2. All right? And another important point to make for y-intercepts, okay? Think about how many times it crosses the y-axis, and here, 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 here. If you think about it, it only ever crosses the y-axis once. So always, you always have 1 and only 1 y-intercept, okay? Now, the domain we talked about being in the past all the x values, right? So look at your graph and see what x values you have. Range deals with all the possible y values, okay? We're going to be looking at examples of those, so we'll hopefully cover that if you have any issues with it. And the last thing that I want to show you is what we call the axis of symmetry. And if we look at all these pictures that we've drawn, okay, I'll draw a bunch more actually. If you look at all these pictures that we've drawn, well, let's look at the most basic parabola right here. The axis of symmetry is the line that splits this thing in half, 2 equal halves. So you can see that it goes right down through the middle, right? So it's a vertical line that passes through the vertex. And it's always in the form x equals something, right? For example, here it's x equals 0, okay? If I slid this over and say it was, I don't know, say this was my vertex right here, down there, right? Boom, 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 runs right down the middle. In this case, my axis of symmetry would be x equals 2, all right? So these are the basic ideas of what parabolas are, and now we'll look through a couple questions. Okay, so first of all, let's have a look here. Now, if I gave you this function right here and asked you to find the x-intercepts and the y-intercepts and the axis of symmetry, okay? First of all, if you wanted to find the y-intercept, okay, you know that x is equal to 0. So that means that it would just be negative 15. It's just the c value, right? 0, 0, gone, gone. Y is equal to negative 15. If I'm looking for the x-intercepts, right, that's where y is equal to 0. So this now becomes 0 is equal to x squared plus 2x minus 15. And then we factor it, right? Okay, see if you can factor it. See if you can solve it before I do. 15, right? 5 and 3. I want a plus 2, so it's plus 5 minus 3. That means that x plus 5 equals 0, or x is negative 5. We have x minus 3 is 0, or x is equal to 3. And if we plot that up here, boom, boom, right? 1, 2, 3, 4, 5, negative 5, and 1, 2, 3, positive 3, right? So there's my y-intercept, there's my x-intercepts. The one other thing that I'd want to find would be the axis of symmetry. And if these are the points, then the parabola is going down like this or up like that. It's just going somewhere. It's going through those points. But what you know is that the axis of symmetry runs right down the middle. and that the vertex lies somewhere on there. So the axis of symmetry, in this case, since it's 8 apart, it's 4 from each side, and it ends up being x is equal to -1 is your axis of symmetry. Okay? Now, here's another question. If I gave you this graph right here, could you find all the information too? What would be the vertex? Okay, the vertex here. Well, identify the point. It's 2 and -1, right? Your y-intercept. Well, that's y is equal to 3. Your x-intercept. Well, that's x is equal to 1 and 3. What else can we find here? We can find your axis of symmetry, which is x is equal to 1 right down the middle, x is equal to 2, right? Part of the vertex. What else can we find? Well, the domain. The domain, well, all x's can exist in both directions, so x is an element of all real numbers is what we look at. And then the range would be y is, okay, all the y values. Well, this graph exists everywhere above -1, so greater than or equal to -1. Okay? Sometimes you won't be able to identify it. Maybe the vertex will be kind of like in the middle there. You just have to do your best and make a good guess. All right? Now, let's have a look at another question here. We go, the vertex passes through the vertex is 5, 2, and passes through the point 7 and -2. Well, you know what? Let's just use another graph. Grab some graph paper, plot it up. 1, 2, 3, 4, 5, 1, 2. There you go, that's the vertex. And then 1, 2, 3, 4, 5, 6, 7, and -2. That's another point. So if that's the vertex, you know it's coming down like this. You know it's got to be doing that. One other thing is that you know the axis of symmetry. So you know that if it's 2 over that way, it's 2 over that way, and you're the same, you just reflect it, make it the equal thing, right? So there you go. So now you have another point. You can get an idea of what it's looking like. Right? You can always reflect those points if you know the vertex. Your axis of symmetry runs right down the middle. You know that your x-intercepts are going to be somewhere in here. We'll learn how to make those functions down the road. Okay? So there's a bunch of different types of questions that you're going to get asked here. I would suggest graphing them and doing the best you can. Okay.